everyone. Am I audible? Hello.
Yes, yes,
And my slides are visible.
yes.
So very good afternoon, good evening to everyone. I am Ashmita Das, PMRE Research Scholar from IIT Guwahati. Today we are going to discuss some problems related to the chapter 7 or week 7, that is biopolymers, which is coming under course PT44 medical biomaterials. So here comes the first question. Alpha glycosidic linkage is formed when OH on the carbon 1 is in the same plane as the glucose ring, above the glucose ring, below the glucose ring, and above the phenyl ring. So what is the correct answer for this question, anyone?
Below the glucose ring,
Okay, so the correct answer is below the glucose ring. So this is coming for this glycosidic linkage. It is especially coming for a very well-known concept that is disaccharides. So can anyone tell me what is disaccharide? This glycosidic linkage concept is a very well-known concept that is disaccharide. So can anyone tell me what is disaccharide?
Monosaccharide joined together and form disaccharides.
When two glucose rings are joined together, then this structure is known as its forms, or two monosaccharides are joined together through a linkage, then it is known as okay. So the glycosidic that is basically uh, when two monosaccharides are joined together through a linkage, that is known that linkage is known as the glycosidic linkage. This glycosidic linkage is basically occurs due to the condensation reaction between the alcohol of the neighboring uh, monosaccharides, and after through the condensation reaction water is removed, and there this linkage is formed. So there are basically two types of linkage. One is the alpha, another was the beta. Like for alpha, which happens in the case of alpha, the two OH groups which is present on carbon number 1 and carbon number 4 should be in below the plane. Then these types of bonds is known as alpha bond. And if one is above the plane and another one is below the plane, then the bond which is formed through the glycosidic linkage, which is shown in this particular image, the this bond which is connected, this particular bond is known as uh, glycosidic linkage. When the both the OH atoms is present below the plane, then this is known as alpha, and when one is above the plane and another one is below the plane, then it is known as beta glycosidic linkage. It is basically based on the stereochemistry of the glucose material or monosaccharides. So anyone have any question?
Ma'am, your presentation is not visible, ma'am.
Sorry?
Your presentation slides are not visible.
Okay, just a minute.
It is visible.
Is it visible now?
Okay, okay. Ma'am, for me
Yes.
it's not visible. Okay, I'll check, ma'am.
For me also, it's not visible.
So I will suggest you to uh, leave and again join. Maybe some connectivity issue is there. Some of it's visible and one is visible.
I actually
Visible,
I
madam.
left and joined, ma'am, but also it is not visible actually.
It is visible now.
Okay, maybe some connectivity issue will be there, I guess. Now moving to the next question. Okay, is the presentation visible now?
Yes.
It is not moving. Okay, now moving to the next question. The question is, glycogen has alpha linkage, beta linkage, gamma linkage, or delta linkage? Can anyone tell me what is glycogen? Anyone? Anyone, what is glycogen?
It is a glucose storage in animals.
Yeah. So anyone else?
It's a polysaccharide.
Okay. Any else? Anyone else? Glycogen is a multi-branched polysaccharide of glucose. It is basically works as an energy storage in animals, fungi, and bacteria. And it is also the main storage form of glucose in human body. So if we see it usually has the alpha linkage. So if we see the structure of this is the outer, like it is a very microscopic structure where there are several branches which is coming out from that structure. So it is known, that's why it is considered as multi-branched. And this one, the monomer of these polysaccharides or uh, polymeric carbohydrate is glucose. And there are several branches, and in glucose, the one glucose molecule are attached to other by the alpha 1,4 linkage, whereas in the order to make in the branch point, a linkage is usually alpha 1,6 linkage. So there are basically two linkage in glycogen. One is alpha 1,4 linkage, which is help to join one glucose unit to another glucose unit, as I discussed in the just previous one. So alpha linkage means what? Alpha linkage means all the hydroxyl ion present in carbon 1 and the OH group present in the neighboring carbon atom or carbon atom number 6 should be below the plane. So in this case, the glucose molecule each other are connected through the alpha 1,4 linkage, and the joining of the branch points, the linkage is alpha 1,6 linkage. Okay, anyone have any doubt in this part? So in both, it mainly has alpha linkage. There is no beta, gamma, or delta linkage present here. Anyone have any question? Okay, now moving to the third one. In DSC thermogram, freezing bound water will show a phase transition at a temperature. Anyone has any answer for this question? What is DSC thermogram freezing bound water will show a phase transition temperature. Please, whatever like guess you have, please try to interact. So the correct answer is less than 0 degrees centigrade. The transition of freezing bound water occurred in the TSA thermogram is lower than 0 degrees. Moving to the next question. If equilibrium swelling is higher in basic than acidic condition, then it is a so anyone have any answer in mind? Can anyone tell me what is the equilibrium swelling? Can anyone have any idea what is equilibrium swelling?
So is it related to any solvent is penetrating inside the polymer?
Yeah. Anyone else? What is swelling in the polymer? What is the meaning of swelling in polymer?
Volume changes, no?
Sorry, actually your voice
Vol-
is not.
volume changes. So,
Okay. Can you just find having more like in like mechanism how it works and why it happens?
no, I don't know.
Anyone? Okay. So swelling is the process when it happens, like when a polymer comes in contact with a solvent, the molecules of the solvent try to penetrate the polymer and bond with the molecule, causing it enhances the volume of the polymer. This process is known as swelling. So suppose this is a polymer strip, and you keep inside one solvent, any solvent. Then what happened? It tried to increase the size of the polymer, because this molecule the solvents try to attach to the monomers of the polymers through various bonding, such as hydrogen bonding or even the covalent bonding. So this process is known as the swelling. And the equilibrium swelling happens when the polymer by equilibrium swelling is the process by which the polymer absorbs a solvent until it reaches a state of equilibrium, where the rate of solvent uptake and the rate of solvent absorption will be equal. So equilibrium swelling means it is equals to it occurs when rate of solvent uptake rate of solvent uptake equals to rate of rate of solvent desorption. Okay. So now if we move to the question, okay. So then this equilibrium swelling, it has a various practical application, such as in drug delivery system and also in the production of other soft contact lenses. In this application, polymer is designed to swell to a specific extent in order to release the drug or allow for comfortable wear of the contact lenses. So apart from that, if we move to the question, uh, if I go for this, the answer is the anionic polymer. The answer is the anionic polymer because uh, at basic condition, the polymer usually contains negative charge. The polymers, anionic means the polymers usually contains negative charge. But when it binds, if the solvent and the solvent contains in the basic condition mostly, these negatively charged polymers are reacted with the positive group present in the solvent, and because of that, the anionic polymers are usually have higher swelling ratio in basic condition compared to the acidic condition, because the in the acidic condition the majority of the ions are positive, and therefore this uh, interaction is not fruitful, whereas in the case of anionic polymer the swelling is more fruitful. If the equilibrium swelling is higher in basic than another acidic condition, it is possible that material should be studied as anionic. Anionic materials have negatively charged functional groups that can interact with the positive charge ions on the soil. In acidic condition, these functional groups may be partially or fully protonated, reducing their negative charges and the ability to interact with the cations. In basic condition, on the other hand, these functional groups will be deprotonated and increasing their negative charge and therefore their ability to interact with cations, which leads to increase the swelling. Now moving to the next question, which does not form a hydrogel. So the correct answer is polyethylene. The polyethylene does not form hydrogen. So hydrogen, can you now tell me what is hydrogen? Hello? Can anyone tell me what is hydrogel? Anyone?
Hydrogel is a flexible membrane, ma'am. Is used in drug delivery systems.
The hydrogen basically a type of polymer material that contains large amount of water in their three-dimensional structure. The hydrogen usually comes from two simple words. One is hydrophilic, that means the water-loving material. Another one is the gel, which denotes the state of matter in which solid is dispersed within a liquid. By combining these two terms, hydrogen term is formed. So it's basically a material which can contain water in their three-dimensional. It is a unique material because it has absorbed and retain water up to 1,000 times of their own weight. So in this case, PVP, polyvinyl pyroledone, hyaluronic acid, polyethylene glycol are examples of polymer that can form hydrogen under appropriate condition due to their ability to form physical or chemical crosslinks between the polymer chains. What happens? The three-dimensional structure of the hydrogen polymer is designated by the porous and interconnected network that allows diffusion of water and solute through the material. And because of that, it usually forms these structures like this. So because of the porous structure, water can easily enter and can retain inside the structure. And because of this material has a high amount, they are hydrophilic polymer, so they can easily interact with water. Whereas in the case of polyethylene, it is a hydrophobic material and does not readily interact with the water. And and the functional group it carries mostly. So because of that, there is no interaction with the water. So therefore, the polyethylene are not suitable for the hydrogen formation. Now moving to the next question. Okay, so the next question is okay, so the next question is PET has a Young modulus of 3.5 GPa and PLG has 1.2 GPa. A polymer blend is prepared with 40:60 mixture ratio. What is the Young modulus of the blend? Please everyone try to calculate one and let me know.
லாஜிக் அப்ளை பண்ணி தான் நான் பாஸ் பண்ணியிருப்பேன். எப்படி தெரியுங்களா? 5A 5B 5B இப்படி மாற்றி மாற்றி எடுத்து வச்சுக்கிறேன். இது இல்லையா 4ல ஒன்று கரெக்டாக சிக்கும். அது மாதிரி தான் எக்ஸாம் அந்த எக்ஸாம் எழுதுனேன். மெக்கானிக்கல் பார்க்குறேன். எதுல நமக்கு நேரம் எனக்கே இப்படி இருக்குன்னா மெக்கானிக் வெறும் மெக்கானிக் மட்டும் படிச்சவனுக்கு
அதுல எல்லாமே கலந்துருக்குமாம்மா.
அதுதான்
நீங்க மெக்கானிக்கல் கொஸ்டின் பேப்பர்னு சொல்றீங்க, ஆனா மெக்கானிக்கல் இருந்து கம்மியா தான் இருக்கு.
அப்ப எலக்ட்ரிக்கல் டஃபா இருக்குன்னா மெக்கானிக்கல் எழுதுறவன் தான் கஷ்டப்பட்டுப்பான்ல. என்ன சொல்றது? நான் சொல்றது புரியுதா இல்லையா? செகண்ட்ல எலக்ட்ரிக்கல் மெக்கானிக் கலந்துருக்குன்னு சொல்றேன். நானே எலக்ட்ரிக்கல் நிறைய தப்பு பண்றாங்க. அவனும் கஷ்டப்பட்டுப்பான்.
ஆமா ஆமா.
Anyone able to solve this question? Anyone able to solve this question? Okay, so first we'll write down some of the information which is already mentioned in the question. The first one is the Young modulus of PET, that is 3.5 GPa. Then PLG, it's 1.2 GPa. Now it comes a polymer blend, it's prepared with a 40:60 mixture ratio. So 40:60 means here PET is to PLGA. Equals to 40:60. So can you tell me what is the PET amount? So PET amount is 40% and PLG is 60%. Suppose. So now we calculate the fraction of PET. Fraction of PET means 40 divided by the sum of the total mixture. So here it is come as 40 plus 60. So as per the formula, it's come as fraction is come as 0.4 and fraction of PLGA. It's not PET, it's PLGA. PLGA is come as 0.6. So according to the mixture rule, Young modulus of the blend equals to the fraction of PET into the Young modulus of PET plus fraction of PLGA into Young modulus of PLGA. So from the fraction of PET found, the value is 0.4. So 0.4 here into 3.5. The Young modulus of PET is come as 3.5. So we put 3.5 here plus into again 0.6. The PLG fraction is 0.6 into PLGA Young modulus is 1.2. So 1.2. So after multiply, it's come as 1.4 and 0.72. So after summing up, we found 2.12 GP. Okay. Anyone have any doubt in this question? Anyone have any doubt?
No, ma'am.
Okay. So now moving to the next question. The question is PET has a Young modulus of 3.5 GPa and PLGA 1.2 GPa. A polymer blend is prepared with 40:60 mixture ratio, and calculate the percent load borne by PET when the blend is subject to a load. Please try to solve this question. So anyone able to solve this question? in this for this study, assume one thing, that is the load is distributed evenly. The load is distributed evenly between the two components of blend, and we can also assume that the load bearing capacity is proportional to the Young modulus of the each component. So the Young modulus of the blend is equal to the fraction of PET into the Young modulus of PET, the fraction of PLGA. So the Young modulus of PLGA as per the previous question. So the value is come as 2.12. So then we are now going to calculate the load bearing capacity in percentage of PET in blend. The formula is the Young modulus of PET in blend divided by the Young modulus of PET in blend plus Young modulus of PLGA in blend into 100. So can anyone tell me what is the Young modulus of PET in a blend and how can you calculate that one? So the PET of Young modulus of PET in the blend is calculated through as per the previous question, that is this only using this formula, the fraction of PET present in the blend into the Young modulus of PET. This formula also defines the Young modulus of PET in the blend. Only this part. Similarly, from the fraction of PLGA and multiplication of Young modulus of PLGA, we can calculate the Young modulus of PLGA in the blend. So from that, we can calculate the Young modulus of PET in blend, that is comes as 0.4 into 3.5. So the value is comes as 1.4. So it is 1.4 divided by 1.4 plus 0.72. So or this particular thing can be also mentioned as the Young modulus of the blend. So it can be also defined as the ratio the component of the Young modulus. Suppose there are two components A and B. So the load bearing capacity of component A can also be written as the Young modulus of A divided by the Young modulus of the compound or the overall material. So from there, the value is get as a 66.04. So this part is clear to everyone, this question. Okay, so if this question is clear to everyone?
Yes, ma'am.
Anyone has any doubt? Now moving to the next question. The PET, the first part is same. If after 10 days, half of the PET and one third of the PLG is degraded, What is the Young modulus of this blend? Please try to solve this question. Similar type of question we have already solved this session. Please try to solve it. Then give me the answer. Anyone able to solve this question? Daisy?
No, ma'am.
And Sridhar, anyone find able to lead how to solve this question?
Ma'am,
Hello. Your voice is not audible, Sridhar. So the process of solving this question are very similar to the first problem, where uh, we find out the Young modulus of the blend. Here in this question, as per the previous one, the information is given as Young modulus of PET, Young modulus of PLGA, and the fractions. So here what happened? The fraction is considered degraded or deteriorated. So for that, the fraction of PET is considered as half. So if the half is degraded, the remain will be half. So 0.4 into half. So the value is come as 0.2. The second one is 1/3 of the PLGA has degraded. So if 1/3 is degraded, the remaining will be 1 minus 1/3. So that come as 2/3. So 2/3, if we calculate, the value is come as 0.67. So it took this one 0.6 into 0.67. So the value here is come as 0.4. Again, we use the mixture rule, which is basically the fraction of PET remaining into the Young modulus of PET, fraction of PLG remaining into the Young modulus of PLGA. After the similar process, we get the GPA is 1.18 GPA, which is much lower compared to the actual Young modulus of the blend. Now moving to the next question. Natural fiber reinforced PMMA is prepared for a biomedical application. The modulus of the fiber and PMMA are 205 GPa respectively. In order to achieve 145 GPa modulus, how much fiber should be added? Use the mixture law. Should be added in volume percentage. Anyone able to solve this question? Anyone? Any answer? So composite, can anyone tell me what is composite material? What is composite?
More than two materials combined together.
And what are the two phases existed in the composite, like
Matrix and
the
reinforcement.
components? Sorry?
Matrix and reinforcement.
Yes. The first one is the matrix, which is present in the larger amount, majorly, but it's not necessary. Sorry, matrix. And second one is the reinforcement, which is basically help to modulate the property of the material, of the matrix material. So here in this case, in this case, the natural fiber is the reinforcement and PMMA is a matrix. So if we go by the answer, the modulus of the composite can easily calculate as we solved the previous question as a polymer braid. The formula is same. The fraction of the reinforcement into modulus of the reinforcement plus fraction of the matrix into modulus of the matrix. So if we rearrange it as per the question, the fraction of the fibers or the fraction of the reinforcement equals to modulus composite minus the fraction of the matrix into the modulus of the matrix the fraction of the matrix into the modulus of the matrix divided by the modulus of the reinforcement, but in this case, the modulus of the fibers. So now, for our convenient, we assume the fraction of the fiber as small v. So small v equals to the modulus of the composite is given as 145 JPa. So we write down 145 in the place of modulus of the composite. Now the fraction of the matrix. The fraction of the matrix is basically if we go for fraction, so it should be the one. If there are we consider there are only two components. One is the natural fiber, another one is the PMA. So if the fraction of the fiber is V, then the fraction of the matrix will be 1 minus V. So we write down 1 minus V, the modulus of the matrix. So here the PMMA is the matrix. So the modulus of the PMMA is 5 GPa. So we put 5 here. Now the modulus of the reinforcement is the natural fiber. So it is 200. So we put here 200. So now we do the cross multiplication. So after the cross multiplication is come as 200V equals to 145 minus, if we multiply these two terms, then it comes as 5 minus 5V. So from there, okay, sorry. So now after we get do this calculation, it comes as it comes as 195. So 200 V equals to 145 minus 5 plus 5 V. So it comes this side. So 200 V minus 5 V equals to come as 195 V equals to 140. So V equals to come as 140 divided by 195. So the answer is come as 71 point. The value is come as 0.7177. So approximately we can say as 0. Don't consider this answer. So the value is come as 0.72. 0.72. So 0.72 is now the answer is required in volume percentage, not in volume fraction. So volume, if we want to convert the fraction into percentage, we need to multiply it with 100. So the value is come as around 72%. Okay. Anyone has any doubt in this particular question? Okay, so I mentioned some of the book in the question in the chat box. You can try. Okay. So you can try to solve. Take the reference from those books. If you need to solve more questions. So anyone have any doubt or any question? Anyone have any question? Okay, anyone have any further question or any discussion?
Oh, ma'am.
Yes?
No, no, ma'am. I said no.
Okay, anyone have any doubt? Okay, so we are stopping today's session. Thank you, everyone.